Here's section 7.6, exercise, what the heck is this, 19? And so they'd like us to find the center of mass. We have y equals minus x squared plus 4x plus 2. And y equals x plus 2. And they'd like the center of mass defined by the intersection of those curves and so forth. Well, so I know the first one here is a parabola opening down that goes through 0, 2. And, so does something like that. And then the second one is a straight line that also goes through 0, 2 with a slope of 1. So we have something like that. So we're interested in that area. And everything's good here. I mean, I know this goes from 0. The question is that, well, I could set the two functions equal to each other here and get those expressions equal and solve for x. I could also simply graph that in Desmos, and that's what I did here. So there's the parabola, there's the straight line, and here, just to help visualize, I shaded between the two. And so we have that, and if I click on one of those lines and hit the points there, I can see, yep, 0, 2 to 3, 5. Okay, great. So this is at 3. And so now we need the mass, m. And again, the mass, we just take areas and multiply by the density. So a given area at some xi is just the width of our interval, so delta x, and the height is the difference of the two curves. So actually, I guess I should write that somewhere. We've got minus x squared plus 4x plus 2 minus x plus 2, curve on the top minus the one on the bottom. So our function heights here for any given x value are minus x squared plus 3x. And so our mass is just adding up all those rectangles. So we have 0 to 3. Again, they tell us it's a constant density rho. And so 0 to 3, and then we take that representative height, minus x squared plus 3x, and multiply by the width, the dx, and we just add all those up. And so that's rho times minus x cubed over 3 plus 3x squared over 2 from 0 to 3. And so that's rho times a minus 9 and 27 over 2. So yeah, I guess plus 27 over 2. So that's 18 over 2. That's a minus 18. So we get 9 over 2. So 9 over 2 rho. And there's our mass. Okay, then we want m sub y. And again, our picture is that we're working with something like this. And so for m sub y, we're measuring from the y-axis, coming over. How far over are we? Oh, well, I can tell you that just by giving you x sub I and then multiplying by the mass of that thing. We know the mass of any element is, again, it's just the, whatever that was, x squared minus x squared plus 3x, okay, times that dx. And then, so there's our mass of a given item, and then the distance out is that x that we are there. And so then our m sub y is just that integral. Again, we have the density times our, so when I set up here we had our mass, I should have had a rho times that. So there's our mass. And we have x times minus x squared plus 3x dx, and again 0 to 3. And so that's rho times the integral from 0 to 3 of minus x cubed plus 3x squared dx. And so we get rho times a minus x to the 4th over 4 plus x cubed, and that goes from 0 to 3. So that is rho times 3 to the 4th is 81, so there's a minus 81 over 4 plus 3 to the 3rd is 27. Okay, well, 27 is what? 108 over 4, so 108 minus 81 is 27. So this is 27 over 4 rho. Okay, so at this point then, we have our x bar is our my over m. And so that's 27 over 4 rho divided by 9 over 2 rho. Rows, of course, disappear, and we get 3/2 when we invert and multiply. So our x bar is 3/2, and we'll look at those in our picture here in a bit. So that's 3/2. Now we need to do our m sub x, and again we have something doing thing like that. Now here we're measuring from here. Well, once again we can get our mass of our rectangle, so that's our rho times the difference of those two things, which was minus x squared plus 3x. So we had that, and times our dx, or delta x. So again, there's our mass. And then the distance, we are just going to use the average height here for our distance. Again, because we have a uniform density and excuse me, uniform density as we go from top to bottom. And so we'll just take the middle of that thing. Well, I have to, excuse me, come back to look at what the heck is f of x plus g of x over 2, because that would be our average height. So starting with f of x, we had our x squared minus x squared plus 4x plus 2. So this was minus x squared plus 4x plus 2, and then plus our g, which was x plus 2, all divided by 2. So this is minus x squared plus 5x plus 4 all divided by 2. So we need to multiply that times this thing. So our integral, m sub x is equal to our density times our distance, so minus x squared plus 5x plus 4 over 2 times our minus x squared plus 3x for our getting our rectangle height for the mass, and then dx, and this goes from 0 to 3. Okay, well, so a little bit of algebra work. Right, I'll multiply through by the negative x squared, so I'll get x to the 4th minus 5x cubed and minus 4x squared, and multiply through by the 3x, so that's minus 3x cubed plus 15x squared plus 12x all over 2 dx. So this is rho times the integral from 0 to 3 of, well, we have our x to the 4th, and then it looks like minus 8x cubed, and then plus 11x squared and plus 12x all over 2 dx. And so this is rho times the integral from 0 to 3 of, let's see, what do we have? X to the 5th over 5, but also over 2, so over 10, minus, we'll have a 4, x to the 4th, and then divide by 4, so we'll have an 8 divided by 8, so this is just x to the 4th, and then plus 11x cubed over 6, because we have 3 times 2 there, and then plus, we'll get an x squared, but end up dividing by the 2 there and the 2 from the x squared rule, and so that's 3x squared dx. Wait, what did I do? Sorry. I did the antiderivative, but left the sign. So this is from 0 to 3. So this is rho times 3 to the 5th. 243, I think. So 243 over 10 minus 81 plus 3 cubed is 27 times 11. Well, that's 270 plus 27, so 297 over 6, and then plus 27. Okay, so this is rho. Well, let's see, if I do a little bit at a time, this is, I can make this 81 over, or 810 over 10. So 810 here, all right, minus that thing, I'll get a negative something, negative, well, you get a 7 and a 6 and a 5. So negative 567 over 10. So I'll put those two together. And let's see, what's 27 times 10? right? I can do that as plus 297 over 6 plus 270 over 10. So I'll just do them a few at a time. So this is rho, and 270 and the minus 567, that's almost 300. That's actually a minus 297 over 10 plus 297, whoops, 297 over 6. I love it when things work out a little better. So this is rho times 297 times negative 1/10 plus 1/6. Well, if we go to 30ths, that's 5/30ths and 3/30ths for the negative. So that's 2/30ths or 1/15. So this is 297 over 15 times rho. And so that number is somewhere near 20. But that's our m sub x. So our y bar is m sub x over m. And so that is our 297 over 15 rho divided by, I gotta go way up here, 9/2 rho for our mass. 9/2 rho. So again, the rows disappear, but well, let's see. So we invert and multiply. 9 does indeed go into, and I could have reduced that with the 15 because 3 goes into 297, but 9 goes into 297. So let's start there, and that's 33. So we get 33 times 2 over 15. Well, we can still take a 3 out of the top and bottom, so that makes that an 11 on top, so 22 over 5. Okay, so our x bar, y bar, center of mass, was 3/2 and 22 over 5. So for one, does that seem reasonable? So we can go here and we can just plot that point. 22 divided by, what was it? 22 divided by 15? Is that right? 146? Oh, 22 divided by 5, but that was the height. Yeah, not too good. Okay, so we needed the 3 divided by 2, and then the comma, and then make that that, and as we look there at the point, that looks reasonable. That appears to be a good point there. So this is 1.5 and 4.4, and then we can check some things. We can say that m equals our integral from 0 to 3. Whoops. Try that again. Go up there. 0 to 3. And then, whoops. What we needed to do was take our f minus g. So f of x minus g of x dx. Okay, and we get m of 4.5. I think that's what we had, 5 halves, right? We can do our m sub y. Whoops, need to come back here for m. And then I'm trying to figure out how I do my subscript here, if I can do that. May not have a subscript here. Yeah, I'm kind of missing where a subscript is. Is it in any of our functions? No, I don't think so. So let me just try some. I could call it m sub 1, which actually automatically goes into a subscript. Bummer. Let me. Okay. So notice well, there we go. So now I'm down in the subscript. I'm going to go back. I'm going to call that m sub y. And then I am going to try to delete that. And look at that. Where there's a will, there's a way. So my m sub y is equal to that integral again. And if I could copy and paste real easily, I would, but I can't. So we have our 0 to our 3. And we, I guess what I could have done was, made that shorter and done some f of x minus g of x and named it something, but too late now, I guess. F of x minus g of x, and then times x and dx. Okay, and we got 6.75. And now we could look at m sub x. Oops. Okay, m. 1, 2. And so I'll go back down in there and do that and call that an x. Get rid of that. So our m sub x is equal to our integral from 0 to 3. And in this case, we needed our, again, we needed our mass and so forth. Notice I'm not using rho in any of these since it wouldn't like that, but it just disappears anyway. So f of x minus g of x. Okay, and then times our distance, which was the average of the two, so f of x plus g of x. And close that off and divide by 2. Okay, and then dx. And it says 19.8. Okay, so then if we make the point here of m sub x, it's a lot to go sorry, m sub y. Seems a lot to go through just to get my subscripts, but so m sub y Whoops, there we go, divided by m. And we get 1.5, and then need to arrow over and put a comma and do my m sub x. Okay, and m sub x. Okay, and divided by m. And close off that parenthesis, and you see it's dark blue. Then I do that and it's green, so yep, we did it. Yay. And of course, you know, once I know what the integrals are that I need, you know, I can set it up in here very quickly and easily and get that solution. Okay, so there's number 20.